what I'm going to do is I'm going to try a physics A level at the start of A level physics. So after doing a term of it. So if I get any more than a D, I guess, I'll be gassed. So figure 1 shows a jet engine. Air enters the engine A, is heated before leaving B at a much higher speed. What happens to the momentum? It has to increase because it's being heated up. Explain, using appropriate laws of motion, why the air exerts a force on the engine in the forward direction. Oh no. Okay then, using appropriate laws of motion, why the air exerts a force on the engine in the forward direction. Because the force exerted by B is greater than A. Therefore, Therefore, as the forces are, see all of that. The forces are equal and opposite. Therefore, as A and B are going one way, the equal and opposite force will push it forwards. Thus, the opposite direction. Then, could we talk about the law of inertia or Newton's second law, which would say that it would only move when a force is being acted on it? Sure. Newton law 2 only moves when force is acted on it. Oh, this is going to be a pain to mark. So, in 1 second, a mass of 200 kilograms of air enters A. Speed of this mass of air has increased by this many as it passes through the engine. Calculate the force of the air exerts on the engine. I think I need the data sheet for this one, Chief. Alright, so I'm looking up the data sheet. And it's taking bare long, you know. So, in 1 second, a mass of that much enters A. The speed of this mass of air increases by that as it passes through an engine. Calculate the force the air exerts on the engine. The force the air exerts on the engine. Okay, I found the data sheet and I think, does this bit come under forces, maybe? I think mechanics will have to come under. So that is, where's mechanics? Mechanics is up here. Okay, mechanics. So, calculate the force that the air exerts on the engine. Well, the formulas for force are force equals mass times acceleration. Well, none of these acceleration, so no. And force equals time taken over. And force equals change in momentum over time. So, force measured in newtons, change in momentum measured in kilogram meters per second. And the time taken, well then, so in 1 second, so time is 1, and then is 210 kilograms of air, 570. So would that just be timesing the two together? 570 times 210. So that is approximately 119700. So 2 significant figures is what I've been taught. That everything has to be two significant figures or else you fail. So, when the aircraft lands, its jet engines exert a deceleration force on the aircraft, making use of deflector planes. These cause air leaving the engine to be deflected at an angle or direction the aircraft is travelling. Okay, so the speed of air is the same speed. Explain why the momentum changes. Is that because of Oh no. Explain why the momentum change. Well, there's been a change in the direction, therefore the speed slash velocity has decreased, and as momentum is dependent on speed slash velocity, this would also also decrease. Okay, this is going to take that long, you know. The total horizontal deceleration force exerted on the deflector panel is that kilonewtons. Calculate deceleration when it has a mass of that. So that many kilonewtons, that means kilo is times 10 to the 3 newtons. And a deceleration when you have times 10 to the 4. So acceleration, so the formula for acceleration is change in velocity over time taken. Yes. And the speed is, we did this a second ago, didn't we? Wait, we did it here. So we did the speed per second. Oh no, that doesn't mean it. Oh, actually, it does, because we have this. And let's say it was 1 second, so that's, wait, so we can use this part, so that is 190 times 10 to the 3 equals 7.0 times 10 to the 4 times x over 1. So that's 190 times 10 to the 3 equals 7 times 10 to the 4 times x over 1. So that is approximately 19 over 7 is what I've got. 19 over 7. So change in velocity is that, and change in acceleration equals change in velocity over time. But so I've got that. I'm very confused. Okay, I've got 2.7. Wait, it's meters to the 1. So I have got 2.7, but is that deceleration or is that the speed? But the time, okay, screw it, 2.7 is my best bet because I've just used this formula here. The aircraft lands on runway turning speed of that many meters per second with a deflector plates acting. Calculate the distance it travels until coming from a rest. You may assume the decelerating force remains constant. So is that Suvat equations? So the distance, so that is v squared equals u squared plus 2as. Because then we have acceleration, we have the, do we have the initial velocity? Yes, and we have the final velocity, which is 0. So 0 squared equals 68 squared plus 2 times 2.7 times x. X equals 0 squared equals, typing this into a calculator because it says physics, so I'm allowed. Oh my god. Jesus. Well, that can't be right, can it? Well, I got 856. Well, minus 856.29. So I am going to convert that into 860. And then just leave it as that. Explain why in practice the decelerating force provided by a D may not remain constant due to unwanted variables which are not under the control of humans, e.g. stuff like the plates not properly being lined up up, breaking, or other issues. I don't think, like, although you should really after exam go back and check everything, I'm not going to do that. Okay, waves, I can do this. Okay, microwave, suggest how stationary waves form. Okay then, microwave, transmitter, transmits, microwaves, oven, wall, reflects, microwaves. The waves are both coherent and monochromatic, so that means same frequency, same phase, same whatever the hell wavelength, so they can interfere. So at points where in phase equals constructive interference, so forms antinodes at points where not in phase or a half out, destructive interference, so equals nodes, no energy transfer. Perfect. That's the first question I could do well. Students remove the turntable and place a bar of chocolate on the floor of an oven, then switches the oven on for about a minute. When the chocolate is removed, the student observes there are small patches of melted chocolate with unmelted chocolate between them. Full size diagram chocolate bar. This is because, aren't those like the points where there's most heat? So because the waves would obviously look like points of antinodes, therefore would have most energy. Calm. Calculate by making suitable measurements of the frequency of the microwave used by an oven. Well, the problem here is that I don't have a ruler or something to be able to measure this with. So how do I do this? So obviously, wave speed equals wavelength times frequency. So if these are antinodes, that means that here to here is half a wavelength. I'm doing this on a tablet, so there is no physical way of me being able to do this. Do I have like a ruler or something? The hell are these? Oh, do I have like a ruler? Oh no. Everything's falling apart. I'll find a ruler, don't I? I should really pause this one. Okay, found one. So, if I use a ruler, it comes out with approximately 4.8 centimeters. So 4.8 centimeters between the two antinodes. So that means half a wavelength is about 4.2 centimeters. So convert that into meters, equals 4.2 divided by 100 is 0.048 meters. So times by, well, then it's wave speed because it's a microwave, I hope. That means that is 3 times 10 to the 8 over 0.0 equals 3 times 10 to the 8, 0.048. Oh, Jesus. 6.25 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. That can't be right, but I am claiming the fact that I do have this, which is doing a bit of a madness. So explain why most microwave ovens containing a rotating turntable food is placed. So the whole thing gets cooked as nodes and antinodes will change. Perfect. So tensile strength of four materials, tensile strength and tensile strain. So what's the difference between them? That's a very good question, which I have no question. Tensile strength, stress, the maximum stress a object can take, and tensile strain, the maximum strain, so stretch a object can take. So stress is in squish. So if you push down on it, identify a property of material A using evidence. So the property, low tensile strength, strain, tensile strain. Evidence did not get far. That's the best I can do there. A cylindrical specimen measure has a diameter of that and a breaking stress of that. Calculate the tensile force. Okay, I'm using the data sheet again. And this time we're on material, so is tensile force. So if we look for tensile force, we've got tensile strength and tensile strain. So I've got those formulas pretty much. But what am I meant to do there then? So I might as well just shoot and pray, innit? So I don't know what, oh, that stands for gigapascals. Yeah, I know what that means. Times 10 to the giga is, so it goes micromilli, centi, kilo, mega, giga pascals. That might get me a mark, you know. And 1.5 times 10 to the minus 4. So full send, that over that, that'll give me a big number. Divided by 10 to the 4, 10 to the minus 4, 8.67 times 10 to the 12. I might as well also write down the formula that the data sheet is giving me, which is F over A, because I might as well just take a mark for that one if it does give me it. The other one is tensile strain. So discuss which of the four materials shown on the graph and most suitable for each of the following applications. A cable supporting a lift in a tall building. A rope or cable attached to a person during a bungee jump. Lift for each application. Okay then, so bungee jump. So that has to be strain. So maybe, does that mean that strain is the maximum can lift and maximum can bounce / contract? So in this case, for each application, so for the lift, I would say, would it be strain or stress? I think B would provide max strain stress. I'm not going to give a full 6 mark, I don't know what I'm writing. And cable is D, this one's meant to be B, would provide the most strain. Oh my god. Yeah, fam, I'm writing that much, chill. A wire probe is used to measure the rate of corrosion in a pipe carrying a corrosive liquid. The probe is made from the same metal as the pipe. Shows the probe the rate of corrosion and wire probe sends to radiant pipe. The wire is an unused probe of that and the length of that. Calculate the diameter. The diameter. Okay. So this comes under electricity, and nope. Circular motion, nope. 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 What would it doesn't come under that. It does come under mechanics? Nope. I would love to know this, but I just don't, because we just started. I would really want to know it. Yeah, I have no clue. I wonder if Control F and then resistivity. Resistivity is RA over L, but there's another resistivity. Resistors and resistors. Okay, resistivity is my best. 9 times 10 to the minus 8 equals, it comes out with R and L. So I'm assuming L is 0.5, assuming R is 0.07. So I'm assuming, what does A equal then? Will A be area? I'm really hoping it is area. So resistivity equals times area, so pi times D, well, A over 2 squared. Yep, so let's see what happens. 0.7 times 10 to the minus 8 equals 0.07 times pi times diameter over 2 squared over 0.5. And if we were to just like click the little thing, what does it come up with? Please give me a good number. It gives me 9.4 times 10 to the 4. 9.4 times 10 to the minus 4. And I'm assuming that it gave me a minus number, but like I'm assuming it doesn't have a minus number. In order to measure resistance using a working probe is connected to a circuit shown in figure 7, when R3 is adjusted to a particular value of that amps, calculate the total resistance in the circuit. You may assume that the cell is negligible. Okay then, so we're going back to the stupid thingy-majiggy. I should really know this, to be honest. Well, calculate the total resistance. So, we know that this is the voltage. We know that this is one, this is another. I have no clue what a probe does. And this is, I'm going to assume the current is going around this way. Or will it be going around that way? Wait, so when it's going around this way. Yep. It's going this way, and then it splits up. The current splits up into two. The voltage splits up into two. And there's a resistor here, So when R3 is adjusted to a particular value of the current, the cell is that. So that one is 0.66. Yeah. And we don't know what this is. We do know that here, the resistance, the voltage would split into two, I'm assuming. So that would be 1.5, 0.75, 0.75. I might be being really stupid here. So, does that mean that, yeah, I might be being absurdly stupid. I'm hoping I'm not, but I might be being really stupid. Or is it kept constant? Well, I know we're using V equals IR. So voltage equals, well, potential difference equals amps times resistance. Now the amps is here, and we know that this is 1.5. So I think that these stay constant at 1.5. I think that 1.5 divided by 0.66, so 2.27, so 2.3 would be my best bet. So resistance of R2 is 22 ohms, and R1 is at Calculate the resistance in R1. Calculate the current. 0.66. What? So the resistance in this one is 22 ohms. So what's the resistance in the other one? Okay. So that's a very good question. So the resistance in this one is 22. I have no clue. 22, sure. Actually, it would be a smart to go 0.66 because that's what it says there. Calculate the resistance when the resistance 1 is 2.4. 2.4 current. So V equals IR again. And the resistance is, resistance of R1 is 2.2. Once again, I have no clue. Absolutely no clue. Nope. Calculate a percentage change in diameter when resistance has increased. But what does a percentage change have anything to do with this? No clue. Absolutely no clue. Voltmeter is connected between point A and B. So point A and point between. Yep. Explain without calculation. The reading of the voltmeter does not change when a cell circuit repeats with another cell with the same AFM, but significant internal resistance because I have no clue. Resistance same, volt, different, current, same. Sure, just go with that and hope it works. A photocell is using a photoelectric effect to provide a current. Really? Those are the questions you're going to give me from that topic. Those are the questions you're going to give me from that topic. The topic I know about. And you're going to give me the photoelectric part, the part I haven't learned yet. Electromagnetic radiation is incident. Explain why there is a current only if the frequency of the electromagnetic radiation is above a certain value. Well, that's due to the fact if you do not reach the threshold frequency, no electrons will be emitted. Therefore, that would mean, what would that mean? That would mean that, electrons would allow. Explain why they allow current to be spread. You need the energy to be above the threshold. And do we write the formula? The HF equals work function plus kinetic energy. I see the other way around in it. Yep. Said to explain the effect on the current when the intensity of it is increased. It would increase. More photons emitted. Student investigates the properties of the photocell. The student uses a source of electromagnetic radiation of fixed frequency and observes that there is a current in the external circuit. The student connects a variable voltage supply to a positive terminal is connected with the electron. Photos has a work function of that many electron volts. Frequency is that. Calculate the maximum kinetic energy of the electrons. Well, we know that is H times F equals 1 EV plus, well, kinetic energy, EK. I'm pretty sure that's what it is. Is it? I think so. Well then, so first of all we change that into joules, I'm pretty sure. So 2.1 times 1.6 times 10 to the minus 19. I am pretty sure. So 2.1 times 1.6 times 10 to the minus 19 equals 3.36 times 10 to the minus 19. So if we work out this part, that part is 6.63 times 10 to the minus 34 times 7.23 times 10 to the 14 equals 10 to the minus 34 times 7.32 times 10 to the minus 14 is 4.79349 times 10 to the minus 47. Nope, I have. It's 10 to the minus 19. So it is that number minus 3.36 times 10 to the minus 19. So 1.4 times 10 to the minus 19 is maximum kinetic energy. So use your answer to find the stopping potential for the photosynthetic curve. Stopping potential. I don't know what stopping potential is, to be honest. So what I do know is that PV equals EV, and because they want something in volts, is that just that answer divided by 1.6 times 10 to the minus 19, so 0.89. See, that's something that this pointless worksheet taught us. Well then, sir. The student increases the frequency of the electromagnetic radiation. What thing? What does that have? So, if there's great frequency, that means a increase in stopping potential, because more energy, so the maximum kinetic energy would be greater. Calm. How much do we have there? Okay, I've done this quite quickly, you know. Helium is the second most abundant element in the universe. The most common isotope is the normal one, has a rest energy of blah. Okay, nice. Anti-helium nuclei would say it was meant by an isotope. An element with same number of protons and electrons but different neutrons. Explain why two photons are formed instead of a single photon when helium nucleus. What do you mean why two of them are formed? Surely we just know that because it's an annihilation, so both of them formed. Okay, sure. So it is actually because momentum needs to be conserved. Term needs to be conserved. Two must go opposite directions. Oh, that's easy. Or different opposite, sure. Calculate using data from the passage the maximum frequency of photons produced in that. What data did it give you? Okay, so we know that the frequency, well, we know that energy equals Planck's times frequency. Yeah, we also know that this is the energy apparently, so 3728 mega electron volts, so that actually equals how many joules? That's 32 times 1.6 times 10 to the minus 19, so that is 5.9648 times 10 to the minus 16. Answer over 10 to the minus 34. I have no clue. Okay, let's think about this for a second. So, we know that using data from the passage had said that a nucleus of this isotope has that much rest energy. Okay. Maximum frequency of the photons produced in the annihilation. Okay. So we have this. So we have the answer. And then we have to times it by 2 because times 10 to the minus 16 times 2, which is 1. Wait. So 3728 times 2, then times 1.6 times 10 to the minus 19. Yeah, okay. 1.19296 times 10 to the minus 15. So then we have the energy over 6.63 times 10 to the minus 34 is then that over 2 divided by that, I think. So it's that, and then take that over 2 and then divide that by p. So that is, let's just say 9. 9 times 10 to 23. Nice out of madness there. Complete this equation to possible decay of an anti-neutron. Okay then, so a neutron, an anti-neutron becomes an anti-proton, then an anti-electron and a normal neutrino, because that's 0, that's 1, and that becomes 0. 1, 0, neutrino. Okay, which interaction is responsible for the decay? Weak nuclear, but there is change in quark type. No. Yeah, actually, there is a calm. So now we're just going to mark this and see the amazingness that has just unfolded. Okay, give us a second to get a mark scheme out. So this is the calm. Question 1, increases. Question 2, force change. Wait, what? Explain using appropriate laws of motion where the air exerts a force on the engine in the forward direction. So this says force acting on the air exerts a force same and equal magnitude, opposite direction. Okay. Oh yeah, I should use green for this. So well done. Forces equal and opposite. So equal and opposite. Transfer. Length equal opposite force again. I don't know why I wrote that twice, but I did. And Newton's second law, which actually says in brackets. Okay, I think that's 2. Therefore, I mentioned the absolute first bullet point. Force acting on air. So next one, 1, 2, and 4 zeros. 1, 2, and 4 zeros. Yep. Actually, I'll do that at the end. So 1.4, momentum velocity is a vector. So change in direction. Change in the direction. I only got 1 though, therefore the speed and velocity has decreased. Nope, I just got 1. So next one, 2.7, I don't care about working out here. 860, calm. I can do maths well in me. And rate of intake of air decreases, smaller rate of change of momentum or momentum changes. So due to unwanted variables which are not under control, breaking other issues, no, not at all. Yeah, no, not at all. 2.1, waves are reflected, they interfere, And the direction transmitted wave. Yeah, I actually did get that. I wrote a 6 mark out for a 2 mark. Jesus. So, energy is at its maximum. Most energy, yeah. And antinode, yes. So 2.3. Give us a second. Clear evidence. Oh, yeah, I see it. Basically, they measured it differently to me. They got 0.118. But I still got all of them. I just measured it differently because of tablet issues. 2.4. Explain why turning position of antinodes changed so everything could. Position of node antinodes would change, yes. 3.1. Tensile strength is a force of cross-sectional, and that's original length, so no, not at all. Property, metal is brittle or low tensile strength. A material has a high Young modulus, material strength, shown on graph. Yeah, shown on graph. Well done. So this one, 23. Do I get any? Nope, not at all. Okay, next one. Well, I'm gonna assume material D is chosen for large strain. Yeah. And material for which one? Material D not chosen. Okay, I got 1 because I chose this one right and this one was wrong. But I probably should have written a lot more better than that, but I just had no clue. So this one, 9.4 times 10 to the minus 4, yep, so that's 3. 2.4 is 2.3, yep, and 0.0, nope, and 4.4, 0. Yeah, no, nope. 4.6, any two from correct reference to lost volts. Resistance not changing. Infinite resistance, no. Yeah, no. Actually, let's say it says resistance not affected. Well in 1. And then the final one, this was the one that I was hoping on to do well on, but I didn't. Energy of the photon, yep. Threshold frequency mentioned, plus work. I did actually do that. And electrons emitted. Calm. So 5.2. Increased intensity, more photons. More photons emitted, yes. 5.3. 1.4 times 10 to the minus 19. Yep. 5.4 is 0.89. Yep. And that one is stopping potential would have been greater because the energy of the photons would be greater than the maximum kinetic energy. So increasing stopping potential because more energy, maximum kinetic energy would be greater. Yeah. Even though there's only 2 ticks on it. Yeah. Atom nuclei with more number of proton atomic number, different number of neutrons. Yep and yep. Momentum needs to be conserved. Must go in opposite directions or must go in different directions. Yep. Imagine it picking up in the final bit. Anti-electric. Wait, this one. 8.8887.10 to the 3. I rounded it to 9 and 0. Yeah, anti-proton, that's already there. Anti-electron, neutrino, yep. And weak nuclear. So, let's see. 1, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 9, 20, 21, 22, 23, 24, 25, 6, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. Yeah, Jesus. Well, that is, I think that is because I clutched up in the final, parts of it, I guess. And what am I looking for now? I'm looking for grade boundaries. AQA, Physics, AS. Okay, Okay then, and we're looking for physics. So that goes down to P. I should have just controlled. And then I found physics. Yeah, physics paper 1. Well, I think that's a lie. Well, it says 34 is an A. So well in me, but I don't believe it. So 34 out of 70 equals an A. But I got that. So I cleared an A by a long way. But okay, we're going to look at normal grade boundaries. A level grade boundaries. AQA. Let's go look at the normal grade boundaries real quick. Control F this time in physics. Okay. Physics. Found it. Physics paper 1. Out of 85, it is 69. So if we're doing this percentage wise, there's my good calculator. So that is 70 exactly. 70% exactly. So that would be, if we're looking at this, 69 out of A5 and A star. So that's 8%. 60 out of A5 is 70.5. So technically that is, in normal terms, a B. Obviously this is a lot easier, but apparently that's an A. So peace.